Okay, number 4 has a little bit of a twist to it. It's still going to work. We can do it. Just be careful on it. The first thing you will notice is that the first inequality is not in y-intercept form or slope-intercept form. It's in x-intercept form. In other words, this is telling me where the first line will cross the x-axis, and that's all it tells me. So let's go ahead and graph that one. Just be careful. It's just a little different. So it's going to be x at -3. So I'm going to put a point here and then go ahead and graph the line. And since it is less than equal to, it will be a solid line. So there is x. I don't know what happened just now. Let me try that again. I had a second line to pop in there, so don't want that. Here we go. So at -3, I'm just going to put a vertical line and let that be it. It is a solid one because of the equal sign. Let me go ahead and put that in. There's a solid line because we have the equality component, and it's going to be at -3. And that's really all you can do with that one. The other one is in slope-intercept form. 5/3 is the fraction. +2 is the y-intercept. And I had students to write this every time just because it builds that into their minds. They got tired of writing it, but we just kept writing it because it helps them remember. But that's up to you. So at +2, I'll put my y-intercept, and then I'll start counting from there. Now I know this has a positive slope where I will move up 5 and over 3. So that would be 1, 2, 3, 4, 5, somewhere about right there. Just kind of have to guesstimate on this one. So up 5 and over 3. And then I'm going to go ahead and put another point over here where you would be 5 and over, because I want to see this one, the intersection of those points. So once you get that in there, you can see the pattern of up 5 over 3, up 5 over 3. And I'll connect the dots. Hopefully. That's close enough, I guess. And this one is a dashed line because it does not have equality in the equation there. So this is a dashed line. Okay, now this one's a little bit harder to see because it's not as easy to shade left and right. So let me put it to you this way. This is actually, I think, a better way to explain it, but I think it helps you to get the shade left, shade right thing down first. This is saying, all of this, that y, it's saying to shade, let's say it this way, shade below the line. That's another way on a number line. Left is below 0, so we're shading below the line. And then on this red one, we're shading below the line, or to the left. So the region in question on this one is this little tiny space down here. It's below the blue line, and it's to the left of the red line. Those drove me crazy. And that will happen usually when you have a vertical line. or a straight horizontal line. When you just have an X or a Y equals something or is an equality to something, it's tricky. So you can think left and right of the line or above and below the line. But you want to be below the blue line, and essentially you're below the red line, because on a number line, below is to the left. But that one is tricky. That can really throw students for a loop. Can throw teachers for a loop too.